Hey, what's up YouTube? So here we are back again on the Python BACnet Stacks playground. This is where I have been just keeping all of this exploratory OpenClaw features. I'm just going to put it in this vibe code app 6. So this repository, the Python BACnet Stacks playground, it's a work in progress. This is where I have like all of the AI generated course content for daily mini lessons in Python for anyone that wants to learn Python. These are daily mini lessons, and I think we've got all the way up to what is an algorithm. So I'll probably continue with this at some point in time when I need like a filler or something to do for my weekly trying to do once a week, but commit to this. So vibe code app 6. This is where we also did backpipes and back 0, just demonstrating how to do a read request, read write release, read multiple. Then we got into a priority array and how to do a point discovery in a device. And then also we experimented with BACnet servers, and we made a small BACnet server that scrapes data from the internet, which was web weather data, and we made a BACnet weather station. So it's all in here. And now we're exploring what did OpenClaw do last night. So let me show you. I think it did some cool stuff. Okay, so OpenClaw, like I demonstrated yesterday, it runs in PowerShell. So this is PowerShell, and what I also demonstrated in a lot of the other earlier videos was setting up VS Code and Python, and also Windows App Store, Windows Terminal. So this is a free tool you can get right from the Windows App Store that makes PowerShell look kind of like makes it look like a Linux terminal. So I highly recommend it. It makes things a lot easier, smoother when working with command prompts in Windows. It looks a lot like Linux actually. So where we left off last night, I let OpenClaw run all night long. So let me just get back to where we were yesterday. So I did chat with it a few times. So like so what I wanted OpenClaw to do was extract the Java form of Guideline 36 in a trim respawn algorithm for an air handling unit. And I wanted to have it convert a one-to-one for that Guideline 36 algorithm, because that's been tested in the Niagara framework, which I showed you a little bit yesterday, where that code lives. So the Java code is also in tutorial format here on the vibe code addict repo, which is we looked at on the previous video. So we asked OpenClaw to rewrite this in a VOLTTRON agent. So there'll be a true one-to-one relationship where we did ask it to do I asked it to make one VOLTTRON agent for a via VBox request counting, and then also one for the air handling reset, which I think it said that that architect, that design seemed pretty good. So I also asked it to when I go home and sleep at night, to kind of keep working at this, make it better, watch for so it's not only going to make the VOLTTRON agents, it's actually going to make sure that there's no bugs. And what I demonstrated yesterday in a test bench, at least, test bench environment, where I've demonstrated this tool dozens and dozens of times for the BACnet stack tutorials. So we do have a VAV box and an air handling unit controller. It's just on the test bench. They're not actually doing anything. but they're just here for BACnet devices, and then we can pretend that we can test our algorithm basically for syntax, that we can actually reset the duct static pressure set point and the supply air temperature set point as if it were a real air handling unit system. We can also confirm that the BACnet scraping is working good on the VOLTTRON agent. So it does everything, I think, except for it being a real mechanical system. It's just kind of fake data. So another thing we asked for it to do, basically to back up all of its context. So I also had some ideas flowing in mind. I'm also testing this open fault detection diagnostic platform at the same time too. So maybe I'll just kind of show you something. Right now this is running in two different repositories, but I might combine it soon into one monolithic repository. So let me just get into here. So this was just kind of like one architecture snip I had of like open-fdd. It's capturing the knowledge graph of the building and then crunching some basic fault detection, which is yet to be thoroughly tested. It's still like kind of in the development phase, but right now we're kind of here. Like OpenClaw is setting up, it's basically setting up VOLTTRON on the Raspberry Pi, and it's also scraping data with the VOLTTRON BACnet drivers, and then also open-fdd is scraping data too. So, and there's also open-fdd also has REST API endpoints that the smart building IoT edge device here, let me just zoom in a little more, can actually get useful insights. So basically, this is what I'm kind of shooting for right here. So OpenClaw basically bootstrapped VOLTTRON here. It's set up BACnet drivers, an agent for just for proof of concept that it can save data to a CSV file. And then also this new Guideline 36. So I also asked OpenClaw, since this is on a test bench environment here, to architect out like what would be the best, how to interface, these two applications together. They could even run on the same Linux interface here. So I thought this would be kind of interesting. VOLTTRON is also a full-blown IoT framework, fully funded by Pacific Northwest National Labs and the Department of Energy, fully capable of, doing a VOLTTRON central instance on the cloud. I know there's some vendors like the Ace IoT professionals. They know VOLTTRON really well, so they would be much more powerful than I can ever be in this demonstration. But so it's kind of, that's what I'm kind of shooting for, is kind of how could another smart building IoT vendor interface with open-fdd, and then what would be the most optimized architecture without doing redundant BACnet scraping of the networks, because we could just be getting data from one application or the other. So I'm kind of curious to see what OpenClaw came up with this. Okay, so I asked OpenClaw to document everything on the Python BACnet stacks, or Python BACnet stacks playground in this vibe code app6 directory. So it's going to look, I asked it last night to really give a thorough once over on the open-fdd, the knowledge graphing, and then use VOLTTRON, like I just demonstrated, as the supervisory layer algorithm, edge agent. What did it say here? The especially cool part is this is exactly what you said. open-fdd could become the source of truth for the semantic model. VOLTTRON could consume that knowledge, what points matter, and then actually run the algorithms. which I do think that would be kind of cool too, because VOLTTRON has been around for a long time, and they do have lots of cool algorithms that PNNL has demonstrated for, you name it, the intelligent load control algorithm for, that's more like not demand response, but demand side management. They have the airside RCX, lots of drivers, and lots of proof of concepts PNNL has made. So I told it to run some testing. See you tomorrow. And then I actually came back and told it to, best architect out. So, okay, so let's see what it says. I haven't seen this yet. I can also tell that it did do what I asked it to do. So I committed to GitHub. This is GitHub desktop here. So it made more context, and it so this is the Python BACnet Stacks playground. It added everything I asked it to add, because before I left yesterday afternoon, I committed everything to GitHub so I could see what else that it added. So it added some few things. Okay, so open clause take, which it's running the codex model from OpenAI GPT 5.4. One drink of coffee here. You've got 3 plausible patterns. open-fdd scrapes, VOLTTRON consumes. Best when open-fdd is a source of truth for device knowledge. open-fdd would run its own BACnet Modbus drivers. Point addressing knowledge graphing semantic mapping, VOLTTRON would consume. Normalize the point streams, equipment relationships, validate metadata, potentially maybe even event alarm fault context. Pros, 1 driver, stack to trust, no double polling, easier semantic consistency. open-fdd's graph can tell VOLTTRON what point equipment matter. Okay. Cons, VOLTTRON becomes downstream of open-fdd, and it's dependent on open-fdd's BACnet scraping features. It needs a clean data API pub sub handoff. So basically, when we were in here, it would be requesting data from open-fdd, and then internally inside VOLTTRON, it would be publishing the data to the pub sub, which we looked at briefly yesterday when we looked at the logs in VOLTTRON. Okay, so now here's the other thing. The other option, VOLTTRON scrapes, open-fdd consumes. Best when VOLTTRON is the edge runtime pipeline backbone. VOLTTRON would own edge polling, buffering, edge algorithms, local instances. open-fdd would consume telemetry from VOLTTRON, basically. Pros, VOLTTRON is good at agent pipeline. 1 scrape. Con, easier if you want a VOLTTRON central idea later. Cons, open-fdd uses direct BACnet authority unless integrated. You'd want open-fdd still to validate the validate address model. Okay, so that's something that VOLTTRON does work off of. It does have this campus building mechanical system, and then also down to the VAV box and point level. I forgot it does have this kind of model. So yeah, that would be kind of an issue. Hybrid model. 1 polls, the other verifies selectively. This is probably the strongest long-term design. 1 system is the primary telemetry collector. The other does selective spot reads, commission verification, drift detection, confidence checks. Cool. Option 3A. VOLTTRON is a primary continuous polling. open-fdd is a semantic graph, fault detection, occasional verification reads. Option 3B, open-fdd is a primary continuous polling. VOLTTRON is the edge control algorithms, occasional verification, or on-demand reads. Interesting. what I think is best for your direction. I think the most compelling architecture is open-fdd validation, control plane. VOLTTRON is the edge execution data plane, meaning open-fdd owns the knowledge graph, which is kind of the whole point of open-fdd. And then VOLTTRON runs all of the polling execution. I think it basically does all of the scraping. I kind of agree with that. Where like perhaps open-fdd just runs, once an hour, perhaps, just validating everything if it needs to on the BACnet network. And then VOLTTRON kind of does the algorithms, polling, cloud pipelines, and trim and respond. So yeah, cool. Maybe I'll just have to build this out. This is pretty cool. And then the key interfaces, open-fdd tells VOLTTRON what to poll and how to interpret it. That's the clean service. Pretty cool. So I think this is really neat. I am happy with what OpenClaw came up with here. I was telling someone else too, the Codex GPT 5.4. I've been pretty impressed with it. Like, it hasn't given me really bad results yet that I haven't needed to find something different or use a different model. Like, I've been happy with it, enough to just keep on going. Plus I can use my OpenAI subscription, my $20 a month, and as long as I don't hit my Codex limits. So what I was looking at yesterday was my when you authenticate OpenClaw with ChatGPT. Before I was doing that model routing policy, that I kept on pinging my 5-hour usage limits with Codex. So as long as I'm not pinging this, I've been really happy with, pleased with the results of just OpenAI's ChatGPT subscription with authenticating this, and just it's been working. Okay, so maybe we'll just have to architect this. I might come back to this. So they should run on the same box. Sometimes yes, sometimes no. Okay, this is where I was saying like they could run on the same machine here. So like when we were looking at this, maybe this is the better way of just keeping VOLTTRON on its own device. I was just testing on a Raspberry Pi, which I don't think in production you would use a Raspberry Pi. You would probably use some other more industrial grade edge device. I think like sometimes it's due to Raspberry Pi everything is burned into an SD card on the Raspberry Pi. With these industrial use cases, logging gets written to the SD card very frequently, and it can burn the SD card. So I think you would want to use some kind of like a solid state hard drive, which this is right here, which I showed yesterday. This is a full-blown, it's just an old desktop tower that I converted from Windows to Ubuntu server, and it just has a solid state drive built into it. So this is a whole desktop tower, but I think you'd want solid state, some kind of industrial edge device. Okay, so I might be coming back to this. This is really cool. I think we might just have to make that. Separate boxes. Cool. So I totally agree with like what it came up with. Best no doubt scrape pattern. And if I was actually taking seriously a canonical point manifest generated by open-fdd from the graph. Perv AHUVAV includes semantic role. Cool. So this is like a little bit about the how to use the knowledge graph. I think in the VOLTTRON config file. So VOLTTRON would have a config file for supplier temperature, even though like we asked artificial intelligence to basically do all this for us. So it's doing all of the point mapping, all of the tagging of the data model. So it's doing all of the data modeling for us. Looks really funny right here that it forgot the S in sensor. VOLTTRON consumes that manifest, and then a platform builds. So open-fdd consumes the resulting telemetry, either subscribing to or reading. Yeah, this should be something we would just have to, somehow open-fdd would have to subscribe to VOLTTRON's pub sub, which I think a tool could probably easily be built. I've seen a long time ago, probably not 10 years ago, maybe less than that, in between 5 and 10, there was a proof of concept of integrating Node-RED with VOLTTRON. So I don't know, maybe some feature like that someone could make at like integrating, letting open-fdd read the VOLTTRON message bus. Yeah, cool. So open-fdd knows what the building is, the knowledge graph. VOLTTRON runs the building. So basically, all the agents and everything, which is pretty cool. So yeah, I love this. open-fdd, this AHU serves the AVs, the knowledge graph. These are the right points. This is the right BACnet Modbus addressing. These faults are real. These are semantic mismatches. VOLTTRON, this is the driver framework. So I'll pull it, I'll run the trim respond, I'll log it, I'll forward it to the VOLTTRON central or cloud or whatever. I'll keep working at the edge if the cloud is down. Cool, so it's writing this, yeah. I told it to do a cool kick-ass service. All right, cool, wow, this is neat. So, okay, I'm just gonna tell OpenClaw, wow, cool, great job. How is the agents working right now? Please walk me through the code on the Raspberry Pi. Also, I need directions how to light up the let's see, so this should be the VOLTTRON virtual environment, and make sure those are in the directions for the project, and tell me how to use the vctl commands. So like VOLTTRON, which I'll hopefully demonstrate in a second here, has these commands that you run in terminal in bash. That is, I think it stands for VOLTTRON control TL, something like that. It's VOLTTRON control terminal, commands. So hopefully it'll give it this. And then I also have VS Code. So this is VS Code editor, and I'm SSH'd through the Remote Explorer into the Raspberry Pi right now. So let's just see what it did. So yesterday when we asked it to, while OpenClaw is kind of finishing its things right here, we did ask OpenClaw to do with our BACnet. So our proof of concept was just a CSV scraping, which we did in previous Vibecode apps on this repo. So it looked like it did that pretty well. It rotated the CSV files. It's probably burning the heck out of the SD card, but who cares? It's just a test bench. And so that worked. So it, I'm happy with that. Okay, so this is actually the demo CSV logger agent. That's the agent code that I think we looked at yesterday. So this, as we were looking at yesterday, this is where it's scraping the VOLTTRON message bus, which would have to be a feature to make for open-fdd. Maybe I can reach out to some of the really smart people at Ace IoT and just to see if I think VOLTTRON has an API. If I remember right, there might be newer versions of VOLTTRON where has a RESTful interface built into it. And hopefully OpenClaw can set it up. Okay, so another thing that we should probably look at here is, so we put this in VOLTTRON data. So this is the trim respond, the air handling unit trim respond agent, the VAV request agent. So this is the Python code that it made, where we asked it to convert the Java version of this, which has been thoroughly tested. So yeah, it looks kind of intimidating here, but this is basically the Guideline 36 algorithm. The Guideline 36 spec converted into an algorithm. I'm just kind of looking at the code. So here's a function or method for trimming or trim respond. So it looks like this is a new set point to, if the current set point, then you add your trim value. Pretty cool. This would have to be thoroughly tested in the field, but I'm sure it's like a pretty good start, at least from like a syntax perspective. Like the code works, the BACnet scraping works, and like the next thing is people would probably have to spend a couple days thoroughly validating that the algorithm works from a mechanical standpoint. I'm just kind of briefly looking at some of the numbers, and it seems here like if a VAV box damper is greater than or equal to 95%, that's one request. Just add a half a second glance here, it looks, there's code, 200 lines of code. Okay, so maybe by now we can use the terminal on the Raspberry Pi. Okay, so here we go. What did it tell me to do? I'm just gonna scroll up. All right, so if you want the Pi, okay, so it's telling me to CD into, I'm going to see if I can just copy this. Projects. Wait, hold up. Something doesn't look right. Oh, here's the VOLTTRON virtual environment right here. So I'm just going to tell it, I think this is the VOLTTRON virtual environment. Can you verify and let me know what to do in terminal to validate I want to do a VCTL status of the agents, please. So yeah, at the time of writing this is the OpenAI Codex GPT 5.4. It's been working pretty well. But this could change at any point in time. Okay, what did it tell me to do? So I'll just see if I can run this. That one didn't work. This is just a Python virtual environment. Neither one of these worked. Okay, so Might have a few errors that we probably have to work on. Copy this back into OpenClaw. None of that worked. It might be because OpenClaw had to install Python 3.10. Okay, let's see what this one does. Okay, so it's asking me if this came up, activate it like this. Oops. I don't think that copied. Still not working. Come on, OpenClaw. Might be a little bit of investigating on how to get this running. Not a valid Python. Okay. So I'm gonna tell it remember we had to install Python 3.10 manually to accommodate VOLTTRON because Py 3.13 was too new. Seems kind of weird. Maybe this might just take like a little bit of investigating, but apologize for the delays here. I have heard that OpenClaw does have some issues with memory here. Like there's ways that people are combining like knowledge graphs, like Obsidian, like all these different note-taking apps, and there's ways that you can make the memory much better with OpenClaw with knowledge graphs through note-taking applications like Obsidian. So maybe this is something I think we might have just run into an issue where OpenClaw just forgot how to run Alright, so let's see what this does. So it's removing this VOLTTRON virtual environment and it's going to install a new one. Anyways, maybe this could be just a place to stop here, but like I was pretty happy with these results. So like yesterday, how we demonstrated that OpenClaw was able to set up VOLTTRON, it was able to set up an agent, was able to set up scraping data. I also liked how when it ran overnight and it was looked at the open-fdd application, it was even able to architect how to integrate the two applications together. So I was pretty pleased with those results. Even though this issue is kind of annoying right here, maybe there's just a couple little small bugs or tweaks or something, research still needs to figure out. But I think this is kind of an important piece of the pie, is that whoever would be deploying perhaps VOLTTRON with AI, maybe something like OpenClaw, that it's thoroughly documented. Like if you have to kill an agent, optimizing something in the BAS, that you know how to do that. So that's kind of an important process. But I think the proof of concept is there, so it's pretty neat. And what I want to do is definitely go back through those notes with OpenClaw and its recommendation of architecting how open-fdd could run alongside VOLTTRON, where I think it recommended getting data from VOLTTRON. Like VOLTTRON would be polling the building through BACnet or through its driver framework, which is pretty robust. And then open-fdd is the knowledge graph, which is kind of cool. So the two platforms could, essentially work together. I might just have to do a little bit of research for how open-fdd could get data from VOLTTRON. So we did run into a couple issues here. So maybe I might just give this just one more shot. There's probably just some steps here that just need to be refined. But I'm happy with how this went. It made the agent code. It said that it installed the code. And like the next thing that I would have to do is just kind of get these little bugs worked out here of like making sure that the human right here can also log into the edge device and start, stop, release, kill as possible. So just a few little bugs right here that probably have to get worked out, but I'm just going to stop this video for now, and maybe I'll post another one for what I found. But thanks for watching so far, and hope you guys have a great day.